Grade 9 algebraic expressions, factorization of a difference of two squares. Factorizing difference of two squares. Factorizing difference of two squares. So we already have explained what a difference of squares is. So here we just want to look at how to factorize it. So basically when you are factorizing this, it must be something that goes very straightforward. Now, if you look at your exponent, there is exponent 2 there. So you open two brackets, and in each bracket, you separate this x into two. So one bracket is going to have x there, and the other one is going to have x there. Then you find the square root of 1. The square root of 1, in each bracket you put 1, and the other one you put a negative. That is my answer. I have factorized a difference of squares. That's about it. Let's have a look at the second one. I want to factorize the expression given, which is a squared minus 4. So first of all, I'm going to look at this number here. There is exponent 2, which means I'm going to separate my expression into two A and A. One A in one bracket, the other one in the next bracket. What you do next? You find the square root of 4. The square root of 4 is 2. It's positive 2 and negative 2. That is my answer for that question. That is the difference of squares. It's a very nice calculation, quick and fast. It doesn't need any serious prayer. So here I see this exponent is 2. That means I'm going to separate the 2 into m and another m. And this must be in brackets, m in one bracket, m in another bracket. Then you find the square root of 16. The square root of 16, you put plus 4, and in the next bracket, minus 4. That is your answer for that question. We have factorized the difference of squares. So all the expressions that I have here are the same. If you look at number 4, I have got y squared, which has been separated into y and another y. Then if you square root 25, you get this 5 here and that 5 there. That means I have factorized a difference of squares. Number 5, same story. I just repeated as much as possible to give you idea on how to do this so that there are no mistakes. I square root the 36. So if I square root 36 here, that's how I get that 6 and that 6. Then this is x squared. It gets splitted into x and another x. That is factorization of difference of two squares. Grade 9 mathematics. This is not something that must give us problems. It's something that we must all be able to do. Let's look at number 6. Now, there are no numbers here, but I must see that this is exponent 2. It's an even number. So there is exponent 2 here, and there is exponent 2 there. In that case, you simply open two brackets and you separate the x into one bracket and the other x into the other bracket. Then this y here, we also do the same thing. We separate it into one y here and another y there. So it is the same thing. The square root of x squared and the square root of y squared, they give us the two brackets. So the answer to that question is x minus y, factor of x plus y. Look at number 7. I find, simply go for the square root. Find the square root here and also find the square root here. You have no problems. So square root means we are simply, in formal language, we can say we are simply separating that expression into two factors that are the same number. So square root of 4 here gives us 2. Then a squared gives us 2a. You've got 2a in one bracket and 2a in the other bracket. If you square root 1, the square root of 1 is 1. So you get plus 1 and you also put 1 in the next bracket. That is the answer. If you factorize 4a squared minus 1, The answer is 2a plus 1, factor of 2a minus 1. Number 7, 8, and they are the same. I must find the square root of 25 and I must find the square root of 16. So the square root of 25 is 5. So that means my bracket is going to have 5m in the first part, and in the next bracket I'm also going to have 5m. Then square root of 16 is 4. You put plus 4 in one bracket and you put minus 4 in the next bracket and you close the brackets. This is the answer to that question. So the factors after factorizing 25m squared minus 16. The answer is 5m minus 4, factor of 5m plus 4. So this positive and negative, it does not matter which one you write first. If you write 5m minus 4, factor of 5m plus 4, or if you start with 5m plus 4, then 5m minus 4, the answer is exactly the same. Right, this is difference of squares. So nice and so cute. There can be no reason to sway here. Now, let's have a look at question number 9. Now, number 9, if I look at this number here, and I look at this one, I can't read, they are not squares. I must be now careful here. If they are not squares, then you have to go back to how do you factorize binomials. If that happens, it means there is a common factor that you must take out before you use the difference of squares. Now, what is a common factor? We need the biggest number that can divide into 5 and 20 without leaving a remainder. The highest common factor of 5 and 20, and we know that it's 5. So if you factor out 5, then you're going to put 5 outside, and then if you divide 5 into 5 and 5 into 20, you get n squared minus 4. After factoring these 5 out here, the two numbers that remain inside the brackets, we notice that they form a difference of squares. So we can factorize it further into n minus 1 and n minus 2 and n plus 2. Please be careful with this kind of questions. The difference of squares can be hidden by putting another common factor in. It means you must factorize that factor first before you apply a difference of squares. That is factorization of a difference of squares. In number 10, that is also the same thing that happened. I can see there is a here, and I can see that there is a there. So which means I'm going to take out a as a common factor. Then in brackets, I remain with x squared. This one is x squared, then minus 9. So the x squared minus 9 that I get from in the brackets is a difference of squares. So the answer to that question, take out a first, remain with a x squared minus 9, and then factorize the x squared minus 9 as a difference of squares. So I did the same thing here. If I look at this one, remember a difference of squares, this exponent must be even. But when I look at this one, it's not an even exponent. But however, x, it means x is a common factor. You take out the smaller exponent. So in number 11, the smaller exponent is x to the power of 1. Then the two numbers that remain in brackets now become a difference of squares. You factorize them by taking the square roots of the two terms, and then your answer is done. That is difference of squares. Number 12, I decided to put a fraction because I know that a lot of learners, they don't like fractions. They're like, oh, please, Jesus, come fetch me. Fractions, here we go again. But if you look, you're going to notice that the method, we emphasize this in maths a lot. When you're doing maths, learn methods. The idea does not change. The numbers may be changed, but the idea does not change. So in this case, I need the square root of this number. The square root of 1 over 9 and I also need the square root of 1. And I know that if you square root 1 over 9, then it will become 1/3. So that will be 1/3 of x in one bracket. Then in the next bracket, I have the same number, 1/3 of x. Then the square root of 1 is 1. So one bracket we have plus 1, and the other one we have minus 1. Then my answer is done. I have factorized the expression. Even though they are fraction, the method is the same. These kind of expressions are called the difference of two squares. We need to know how to factorize them, especially at grade 9 level, so that by the time we start with FET grade 10, we have the basics that are needed for you to master mathematics at grade 10 level. So yeah, please practice this and let me know how it is for you.